All right, and so it's this little marginal difference in this case because these aren't very different masses, you know. So they really should do the 1 to 5 or 1 to 10 ratio. That would be the ideal, and then they could show this creation of twice the, 3 times the energy, 100 in, 300 out. But just absolute crap. So let's do.
Okay, so it's been a long time, but I'm back with another elastic illusion experiment. Yes, once again with stupid little plastic toy cars. But this time, instead of a typical 1 to 2 mass ratio, it's a 1 to 5 mass ratio, because draft science would like to see a 1 to 5 mass ratio. Because the more we increase this mass, the more free momentum we will get. Well, at least according to his model creates the free momentum. Conventional science model creates conservation of momentum because we have to subtract the opposite directions. So let me show you the mass. This is the typical one mass. This should be around 33 grams. It's 33 grams times 5 should be around 165 grams. Put that over here, and we have 166.45 grams, or 0.50, doesn't really matter. So this one is gonna come in with an initial total amount of momentum, and then according to draft science, this one can't possibly come out with more momentum than the initial one. This one has to come out with less than, or at best the same amount as this one. But what will happen is this one, yes, even now when it is 5 times as heavy as this one, it's going to come out with more momentum than the total amount, than the total initial momentum. Why is that? Because this one will reflect back with also a certain amount of momentum, and according to conventional science, we have to subtract this momentum going in this direction, and then momentum will be conserved. But draft science refuses to accept that there exists such a thing as a negative momentum, and so this will once again be a free momentum experiment, even though we have increased the mass 5 times as much. So let me give you a short example. Well, I guess I have to, I'm not going to edit anything, otherwise I'm going to be blamed. It's going to be, he's going to blame me of cheating. So I got the flags. Let me measure the flags. Doesn't really matter, it's 2 centimeters. Okay, it's 2 centimeters. The same with this one. It's 2 centimeters. Okay. I got a spring because it's elastic. The timers are perpendicular next to each other. This one is a little bit higher because I have stacked some weights on here, so the flag is higher. So it's going to be like this. Okay, and a little example. There we go. I'm going to place my camera now on top of here and zoom out a bit. Okay, like that. Oh yeah, I forgot the timers. I mean here you can see the timers, of course. Gotta turn that on, and I'm gonna show you each time. So hold on, zoom out again. I'm gonna do like 5 runs, 5 tests, I guess. Put this one over here. All right, let me turn on the timers now, and here we go. All right, so let's check out. All right, so this is for the 5 mass. The timing is 0.0743. This is for the 1 mass, the reflection of the 1 mass, which is 0.378. And then it came in with, the 1 mass came in with a timing of 0.0231. Right now, reset the timers. This is the second try. All right, here we go. Okay, so again, the 5 mass came out with a timing of 0.0928. The reflection of card 1 of mass 1 is 0.0463, and mass card 1 came in with a timing of 0.0267. Right, trial 3. Hold on, yeah, reset. Trial 3. This is completely unedited, so you can't possibly blame me of cheating anything. All right, here we go. This is trial 3. So mass 5 came out with a timing of 0.0836. The reflection of mass 1 is 0.0423, and mass 1 came in with a timing of 0.0251. All right, reset. There we go. Alright, so mass 5 came out with a timing of 0.0780. Mass 1, the reflection of mass 1 is 0.0398. And mass 1 came in with a timing of 0.0240. Okay, so now I'm going to stop the video and I'm going to do the calculations. And then now all the results, all the calculations. So I've written down, all right, so the mass is 0.033 kilograms, and then the 5 mass is 0.16645 kilograms. All right, so the timings are over here in seconds. Then for the velocities, we simply have to divide the length of this flag by the timing, so it's 0.02 meters each time divided by the timings, and these are the velocities. And then we have to multiply the velocities with the masses to get the momentum. And so momentum 1 is 0.02857. This is the initial total amount of momentum. Then the 5 mass came out with a momentum of 0.04479. And as you can see, this is already more than the initial momentum. So this is already a free momentum experiment according to draft science. We already have a 56.77% increase in momentum. It's 56% more momentum than the initial amount of momentum. This is still, we still neglect the reflection. But when we include the reflection, so we do, when we add these two together, this is a reflection, then we have a total of, we have 117.89% more momentum than the initial amount of momentum according to draft science model. Because according to draft science, we always have to add the momenta together. However, if we, according to conventional science, subtract this momentum with this momentum, so with the momentum going backwards in the opposite direction, if we subtract these two, then we have 0.02733, and the initial amount of momentum was 0.02857, so we have lost 4.34% of momentum, which makes sense because in this kind of setup there is a lot of friction going on. So we have lost momentum. And for draft science model, we have gained 117.89% of momentum. Now his explanation is that all this extra momentum is stored in the, a rotational momentum in the wheels. It's all stored in the wheels. So 117.89% of momentum is stored in here. 170%. Apparently, so much extra momentum stored in these little wheels. So that's going to be his explanation, I guess, for where all the extra momentum went. Then trial 2, we have a total amount of initial momentum of 0.02391, and then the 5 mass came out with a momentum of 0.03587, which is already a 50% increase of momentum. It's 50% more momentum than the initial momentum. So it's already a free momentum experiment. Now, so the reflection of part 1 is 0.01425. So according to the conventional science, if we subtract these two, Okay. Then we have 0.02162, which means we have lost minus 9.58% of momentum. Again, we have lost momentum, which makes sense because, again, a lot of friction on this track. Then, however, if we add them together according to draft science, we have an increase of 109.62% of momentum. A total of 109% more momentum than the initial amount of momentum. So this is an insane free momentum experiment. Again, he will say it's all stored in the wheels, all this extra momentum. Then trial 3. The initial momentum is 0.02629, and then the 5 mass came out with a momentum of 0.03981, which means we have already 51% more momentum than the initial momentum. Now, this is the reflection. If we subtract them, so according to conventional science, we have lost minus 7.91% momentum. Again, we have lost momentum. If we add them together, this is according to draft science, we have gained 110.76% more momentum than the initial amount of momentum. Then the last trial, trial 4, the initial momentum is 0.02749. Then the 5 mass came out with a momentum of 0.04267, which is already an increase of 55.22% of momentum. It's already a free momentum experiment, once again. Then the reflection of mass 1 is 0.01658. So when we subtract these two, then we have lost 5.09% of momentum. On the other hand, according to draft science, when you add them together, we have an increase of 115.53% of momentum. 115% more momentum than the initial amount of momentum. So as we can see, for conventional science, in every case we have lost some momentum. We have lost a maximum of around 9% momentum. So we have, let's see, trial 1, we have lost 4%, then 9%, then 7%, and then 5%. So a maximum of 9.5%, which is not an insane amount of error percentage. Whereas for draft science, we have an increase of 117, we have an increase of 109, 110, and 115. All of these trials have more than 100% of increase of momentum for draft science model. So yeah, once again, we have increased this with, it's 5 times as heavy, this card, and momentum is still conserved more or less with an average an error percentage of maximum of a maximum 10%. And we have to subtract momentum, otherwise we have insane free momentum numbers.